So linked list, it is a kind of abstract data type. And we are going to look at the linked list, how the linked list can be connected to the stack, and how the linked list can be connected to the queue. Okay. So what is linked list? A linked list, the name is list. We know a list. A list is a data structure with the square bracket, and we know every element in the square bracket. But there will be a word link. Link. It means there should be a connection between each of the element. There should be a connection between each of the element. First, we will learn about the singly linked. Singly. Singly refers to single. Okay. We call it singly or single. It is a concrete data structure consisting of a sequence of nodes. So this is node. Starting from a head pointer. Okay, so we will learn about head. So it is a collection of nodes that collectively form a linear sequence. A linear sequence means and the front and here the end. Each of the node, we call this is node, it consists of element. Element means the object. So the object can be number. The object can be name. The object can be, for example, the object oriented. It is a shape. So maybe this is a triangle or rectangle. Or if it is an animal, maybe this is about the dog, it is cat. Or if it is about the vehicle, maybe this is a sedan, bus, and etc. So the first is the element, and the other is what is the connection to the next element. So if you look at this one, we know that this is the first position. Because it is the first position, then we will put head. So we know that this is an element of A, and this node is connected to node with the element B. We know that this node is connected to another node. Okay. So we call this is node. We call this is another node. We call this is another node. And we call this is another node. And every node have element and has a pointer. We call this a pointer to the next. So each node stores element, okay, element, and then link to the next node. The application of the singly linked list, we can look at the routing sequence. So if you, some of you in the team project, you want to deal with the traveling salesman problem, or you want to know the sequence. If you want to visit some places, where is the first position, where is the next position, and so on. So you can use linked list. You can use singly linked list. The delete and undo operation. Okay. So if you use like Microsoft Word, you use Notepad and etc., you will have the delete and undo. So it is also using linked list or linked list. Photo viewer. So if you have image, if you look at the current image, so you can go to the next or you can go to the previous. This is also a kind of singly linked. So the indirect application, it can be the auxiliary data structure for list, stack, queue, right? And it can be for the other component of other data structure. In order to understand the singly linked list, we need to understand what is node. We need to create a node class. As I mentioned to you previously, node contain two things. The first is the element. The element means anything, any object. If you create the object about car, then the element will be a car. If you have the object as a student, then the object will be one student. And then we have another object which is next. So it is a connector to the next node. So in this, wait. I'm sorry. It is using Java. Why I put the Java code? I'm sorry. This is using Java. I will update with the Python code later. So we will create the constructor. So this is the constructor with two elements. Okay, after I update it, I will let you know. I'm sorry. So this is one example given in the book about how the linked list works. Whenever we want to add, okay, or remove, so as I mentioned to you, when you have a data structure, so you have at least two operations: insert or insertion and remove. Insert and delete. Insert and delete. So you need to find out how to insert a new element and how to delete the element. So if we want to insert a new element, so we can insert at the head. Insert at the head means, let's suppose we have this data. So this data is a city. I want to visit Rome. And then after I visit Rome, I will go to the next node, which is here. And then after I visit Seattle, I will go to the next city, which is Toronto. So the first visit will be the head. And after Toronto, okay, there is no other node. Now, I changed my plan. Before I go to Rome, I want to visit South, and I need to allocate a new node. It means I will create a node. After I create a node, I will insert the new element. So I will insert the node before the head, and then have a new node point to the old head. So the node here, now the head will be removed and it will be in this new node. So update head to point to the new node. If we want to remove, it is easy to remove the head. So we learn about queue. Okay. We can remove head. So the head means, yeah, we want to update the head to point to the next node in the list. So before we remove it, we change the position of the head. The position of the head originally it is in the Baltimore. Now the position of the head is removed to the next node, and then after we remove to the next node, we remove this node. Yeah, this is a kind of way to remove. Yeah, allow garbage collector to reclaim the former first node. So we want to update into this node. There is another concept, we call it till. Till means I want to add at the end. So head is front and till is end. We can allocate a new node. So let's suppose to be route from Rome, Seattle, Toronto, and then I want to put Zurich. Okay. So we can just insert a new element at the tail. The tail means the last element, and then have a new node point to null. So we call this is null. If the next element is null, then it is the last element. Because we are going to add a new element here. So the new element now it is pointed into null. And then the old last node point now is connected to the last node and then update the tail. So we remove the tail from Toronto and we update the tail. Now it is Zurich. So that's the step for when we want to add a new element at the tail. How if we want to remove an element? So if we want to remove an element at the tail, so removing at the tail of a single linked list is not efficient. Why it is not efficient? For this kind of data structure, if you look from stack and if you look from queue, when we use the stack, the insertion is constant, O1. The removal operation is also O1. So whenever you use this kind of data structure, we want to get the constant time. If you can make a data structure with constant time, that is very best. Because the goal of the data structure is to make your algorithm efficient. But if we want to remove the tail, it is not efficient because whenever we want to update the tail, we want to find out the last element. So the last element, we need to find out from the first. So it means it will be ON. So it is not always constant. That's why we can try to apply additional data structure like stack or queue in order to help the linked list with more efficient operation. Let me stop here. Let's have a break. I will continue after the break.